Meet our HP85. This poor machine died just before we moved office. It's been on the repair queue for a while. In the last week we've gotten it working again. Well, at least there's some value of working. I thought maybe we could make a short series about it. Today we'll introduce you to the machine. Then in the next video we'll have a look at how we repaired it. Still got issues, and as we sort each of those problems out, we'll post update videos looking at the debugging and repair process. For now, let's get introduced. We're happy to have the help of the National Museum of Computing with this video, and seriously folks, you gotta check this place out. The National Museum of Computing is on the campus of Bletchley Park, as in Bletchley Park, home of the Codebreakers in the UK. The National Museum of Computing is a TARDIS of technical history. You'd never believe it would take you most of a day to get through it, but it will. TNMOC can't be a lot easier to get to. You'll find it and Bletchley Park right outside of the Bletchley Mainline rail station. We're going to dip into TNMOC's vast reserve collection to show you some of the Little 85's backstory. For HP, the 85 was already a 4th or 5th generation of desktop computer, depending on how you count. In 1968, HP started building desktop personal computers with this thing. It's an HP 9100. Now if you're saying calculator, then hang on a second. This is a Von Neumann complete computer masquerading as a programmable scientific calculator. In '68, such things were pretty exotic, though this wasn't the only such machine. You already had things like the Olivetti Programma 101. Nevertheless, and relatively speaking, HP's machine was tiny. It doesn't do direct character representation, that I'll grant you, so you won't do any text editing, well, not very easily, and it has a small memory. It could handle a program 196 lines long, no more, but it had a lot of common scientific functions already in ROM, and you can load whatever you want with magnetic striped cards. Sure, it's more limited than things like the contemporary DEC PDP-8 mini computer. Remember though, this is worlds easier to program. There's no teletype required, and it costs about a quarter as much. And the 8 wasn't any faster. You might be able to stick an 8 on a desk and so call it a desktop computer, as long as it was a sturdy desk, and as long as there were 2 of you to move it. But for personal use, this little HP was certainly more user-friendly. HP continued making programmable desktop machines from that point on. After the 9100, they started using more mini-computer-like architectures. The 9100 was a bit of a one-off. Between the time the 80 series came out and that of the original 9100, there was the whole 9800 series of machines. HP had this mini-computer platform, a bit like the PDP-8. It gets retrospectively called the 1000 series. The 9800 series desktop architecture evolved from one of these 1000 series mini-computers. Here's the original. It was actually called a 2116. With the 9800 series, its CPU and instruction set got miniaturized and re-implemented. In 1972, HP scaled its mini-computers down to this. It's a 9830A. Now that's recognizably a desktop computer, isn't it? It's a very busted desktop computer, but that's what it is. If this one would power up, you'd be greeted with a copy of BASIC, just like an Apple II or any other of the famed first-generation micros. Granted, you'd have just one line of red LEDs to work with, but they scroll. HP's early desktops were typically well integrated. That's a cassette drive on the right, so it has built-in storage just like the original 9100 and its magnetic card reader. Oh, and that tape drive is digital. Most mini-computer cassettes of the 1970s are analog. In many HP designs, you also get internal printers. The one for the 9830 sits on top, but it looks like it's all part of the same machine. In 1977, HP desktops brought out their first CRTs with a model 9845. Ah, the hallowed 9845. I've never gotten ours to work, and yet it's already my personal all-time favorite computer system. Dual tapes, 16-bit processor, built-in full-width printer, friggin' gorgeous! But I digress. The 85's introduction was the first time HP marketed one of their desktops as a personal computer. In truth, most of the desktop systems they made could have carried that label. Remember, HP saw its users as engineers and technicians, so the 85 is meant for factories and labs rather than bedrooms. Yet HP had been watching the emerging micro and home computer market. While much of this machine's design plants a firm foot in the engineering computing world, it dangles the toe of the other foot in the waters of home and consumer computing. In 1980, the 85 arrived as this refactored, compact, streamlined package. The 85 is completely integrated. It's all there: keyboard, monitor, tape drive, printer, one box. The printer is this thermal job up here. I know what you're thinking, but for the technical use case this machine's designed for, it's actually fine. And have you ever seen the printer on a Sinclair Spectrum? It only really sucks if you're trying to publish your magnum opus. And yes, that really is the screen. All of it. Titchy, but again quite usable so long as you weren't attempting to do WYSIWYG desktop publishing. 5 inches will have to suffice. Over here is the tape drive. It takes digital cassettes, a feature and format common across a lot of contemporary HP products. Fun fact, it's portable. Ahem, supposed to be portable. HP's user base were supposed to be techies. This was a machine designed so the engineer could take it home at night, just like his pocket protector and mechanical pencil. They made it light. They even made a bag for it. At 20 pounds and another 5 for the world's most over-engineered laptop bag, you could literally struggle across the car park with it and put it in the boot of your car. Try that with a Commodore PET. I have, and it's not recommended. This part of the back, it's actually critical. Here you have 4 stacked cartridge slots. The cartridges can be ROMs, just like in your home micro, but they can also be the mechanism for expanding the system. And you can add a wide range of devices like BCD interfaces, serial ports, modems, speech synthesizers, memory upgrades, and even breadboard adapters. The most important is probably this thing called HPIB, also known as GPIB, and if you're not familiar with it, it was the standard interface for instrument control over the course of a couple of decades. It's a daisy-chainable parallel bus. HP also used it for peripheral interfacing, so this machine can drive instruments, process control, or just interface to disks and tapes over the same general-purpose interface bus. That's what GPIB stands for anyway. If there was an instrument with a data interface, HP pretty much had an adapter for it. The thing that always strikes me about the 85 is the subtle way it's adapted to both its engineering and home computing roles. It definitely does behave like a home computer in some ways. The operating system's basic interface would be pretty familiar to an Apple or Commodore user of the same time period. I can't imagine there was a teenage lad with one of these in 1980. This thing cost about $5,000 US. That's even more than an Apple II. If there was such a lad, he'd have to have been genuinely interested in programming and educational software, because if he wanted to play games, he was going to be sorely disappointed. This machine's as black and white as a ZX81, and its games library was 2 released tapes containing about 31 total titles. Well, I guess you can always make your own fun. So, it wasn't a fabulous games platform, not if you wanted massive graphics. You may also notice that it's, well, to be kind, not quick. In some senses, the CPU is epically slow compared to even the most common machines of the time, and yet this is the cusp of the 85's dual identity. Let's make a quick comparison using some simple number crunching. This is an Atari 800XL. It has the classic 6502 CPU under the hood. Now let's run the same logic on both systems against a stopwatch. This program is a basic Fibonacci series calculator. In other words, it's a program that just adds numbers and updates variables in a loop. In raw compute terms, that's just add, store, load, and jump, practically the simplest things you can ask a CPU to do. First, the Atari. I've written this program to read out only when there's an overflow. The Atari runs its loop 469 times before overflowing. It executes the program loop in an average time of 43 milliseconds. If we implement the same logic on the HP, it averages 100 milliseconds. That's worse than twice as slow. The $200 Christmas special beats the pants off the $5,000 HP. Well, sort of. You've got to consider 2 more things. First, the HP keeps going to about 500 decimal places rather than just 98. Then, let me show you this. Let's just turn off the printed output and run it again. This time, the HP is actually taking 9 milliseconds per program cycle, so the other 91 were just graphics time. Do the same on the Atari, and it takes 11. You see, it's the HP's display routines and driver that are a lot slower, not the processor. The display on the HP is there to show you the data. The programming language and logic are focused on black and white text and graphing. They didn't invest in WYSI display adapters. Atari did that. Each maker knew its market. But aren't they both just using the same processor? Weren't there really only a couple of micros out in the mid-1970s? Well, emphatically no. To make a low-end technical computer, HP created their own microprocessor for this machine. It's called Capricorn. It has a trick for basic mathematical tasks like this. Inside HP's processor, there are flexible registers. A register is the high-speed memory used during instruction execution. Capricorn's registers can store up to 64-bit integers or even a 64-bit floating point number, and it can access those values in a single instruction. Atari 6502 uses purely 8-bit registers. Put it another way, if you want to handle large numbers, you have to crank the handle on the Atari a bunch more times than you do on the HP. The HP is actually optimized for precision in ways that counteract the fact that it's clocked only 2/3 as fast as the venerable Atari. The Atari is all of 1 MHz. The HP, if you can believe it, is 625 kHz. Here's another little factoid. That Atari has 64 kilobytes of RAM. The standard Atari ROM, containing BASIC and the operating system, is 16K. The HP, on the other hand, has a maximum RAM configuration of only 32 kilobytes, but it has 32 kilobytes of ROM. To that you can add multiple additional 8K ROMs using expansion cartridges. Put that in modern programming terms. Your own application can't be huge, but you can make use of a substantial system library with no memory penalty to your app. The library has allowed all kinds of interfacing possibilities. We'll explore interfacing the HP85 with devices and controllers in another video. For now, that's our basic introduction to the machine. Hope you found that interesting. For now, thanks for watching. Please subscribe for more vintage computing and technology videos. And if you liked what you saw, give it a thumbs up. See you soon.